Hi folks, Harry Frank from Red Giant here, and in this tutorial we're going to continue our discussion on Trapcode Form's two mapping sections, the quick maps and the layer maps. This lesson's mostly going to focus on the layer maps section. The layer maps can be quite powerful. In short, what these do is allow us to take an external layer, either an image or a moving image, or perhaps a composition, which is generally the case, what I do, and we can take the luminance, color, and or alpha channel information and map that information to different parameters in the layer maps. As you can see, we can control color, displacement, and don't confuse that with disperse. Disperse is randomness, displacement is movement. Size of the particle, fractal strength, and particle rotation in the case of textured polygon particles. So let's just cover some of the basics with layer maps here. This is one of the things we'll be assembling here, which is taking an external layer. In this case, we'll be using After Effects plugin Wave World. And then on top of that, we'll be laying some text and pushing the text through and displacing particles based on the luminance of the external layer. Pretty simple stuff. So let's make a new composition here. Layer size doesn't really matter. I'm sticking with 960 by 540 lately. And I'll create a layer for my form and go to Effect Form because this is the last effect that I've applied. So I'll go to Base Form, set this to one particle in Z, and we'll rotate this on its side so that we have a flat surface that we're working with, more or less a flat grid of particles. And let's scale this size out in X and Y, which we can't really see because we're looking at it flat on. So let me create a camera, tap C a couple times so we can position ourselves here. We'll come back and adjust this base form, but this is a good starting point. I'll probably need more particles in X and Y just to give us a little bit more grid resolution to work with. Okay, so let's jump down to the layer map section. I actually covered a little bit of layer maps in the last lesson, but mainly I was talking about color and alpha channel mapping, where we can map either the RGB information or the RGB plus alpha information, or just the alpha channel, or map the luminance or lightness to the alpha channel. So let me grab this map that I made here. This is just a composition that I'll paste in here. I'll open this up and show you what I've got. I've got a couple different things in here. So the first one I have is Wave World. Now, what you generally see by default is this wireframe preview. And all I did was take the position of the producer and move it over to the side. So we have these waves kind of rippling across the surface. I'll set this back to a height map, and what this does is render a luminance map of the waves. The dark areas represent a lower area, and the brighter areas represent a higher area of the map, and that's going to be important for us. I also have a text layer here that just says form. It's actually fairly blurred. Let me add a little bit of color to this, just to review the use of color layer maps. So if I go to color and alpha, select that layer of my map comp, and I tell it which two axes to map it. Again, something I say a lot, but it's important to understand. Form works in all three dimensions, up, down, left, right, forward, and back. We need to pick two dimensions because this image exists in two dimensions. It's a flat image. It does not have any Z depth. So we have to pick two dimensions to map in three dimensions. So we could do X, Y, or XZ, or YZ, and then these get a little more complicated, and we'll cover those in another lesson. Generally, what you're going to do is use X, Y. Now I'm going to go back in here and disable this blur filter. Let me turn up the particle size a little bit so you can see this a little bit better if you're looking at this on a smaller screen. So as you can see, we are mapping RGB to RGB, but we'll have black particles where the negative space should be because we haven't told it to include the alpha channel. And we can do that by selecting RGBA. Or we can just pull the alpha channel, and then we are free to use whatever color we want. We can either set the particle color manually, or go into a quick map and map the color with quick maps here. So I could say map the color using this color map here in X, Y, or Z. A lot of flexibility there. I'm going to turn off this color map, and I'll just use a simple color of the particle to color the layer. What I'm more interested in are things like disperse and displacement and all that kind of stuff. So let me go back into this composition, and I'll turn on this layer down here that has wave world. And let's also enable this blur. So I just kind of blurred in this text. In fact, let me leave that off for just a second so you can see the effects of what that blur has. So let's go to Form, Layer Maps, Displacement, and we'll push these particles in different directions. Now, generally with displacement, you're going to want to pick one axis to push this stuff. You can do all three, where we map red, green, and blue directly to X, Y, and Z. So red corresponds to X, and green to Y, and blue to Z. But what I'm going to do is use individual maps, and what we can do is map the luminance to X, Y, and Z. So I'll set this to Z. That would be the up and down axis. Remember, I rotated my base form, so X is this way, and Y is this way. Z is straight up and down. So I'll set this map comp 3 to be my Z displacement layer, and we'll map this over XY. That's the basic standard. That's, well, really the first choice. Now, generally what you'll find is trap code form mostly works in XY. XZ and YZ are fairly rare and generally only happen if you're working with very deep grids of particles using the box grid with lots of particles in Z. If you're just using one grid, XY is the way to go. Now you can see we're a little bit distorted here, so let me bring the size Y down so that we are, well, actually, let's set this to the exact values. 960 by 540. That should be fairly close to what we have here. 960 by 540. So by default, the intensity is 50. I can turn that up quite a bit. And we can see we've got the waves displacing the particles as well as the text. Now I mentioned that I was leaving that text with a hard edge on it. And what you can see is that we've got a hard cut where the particles start to be displaced by that text. If you'd like to smooth that out a little bit, that's where we'd want to blur it. So I have this blur animating from quite a bit of blurriness down to about 24 pixels. And the text is also semi-opaque, so we can actually see the waves through the text. And what that means is that the text will actually float right along with the waves. If we don't want that happening, I can set the opacity to 100%, and then we won't see any of the waves through that text. Well, we are seeing it through the blur. Let me turn off the blur. There we go. They fade up right there. So there's a little bit of transparency while they fade up, and then as they move, they're not affected by the displacement. I kind of like the look of them floating along the surface. So I'm going to leave this at maybe 75%. So like I said, it's important to understand that displacement works with values above and below gray. 50% gray means that a particle is not displaced. White means a particle is displaced 100% in one direction, and black means it's displaced negative 100% in the other direction. Now, things that don't work with that are things like size or disperse. So just for demonstration purposes, let me bring in another map that is a simple gradient that is indeed going from black to white. Now, if I were using this with displacement, the black areas of the image would displace particles negative 100, and the white areas would be positive 100. So that's why this isn't a good idea for using displacement. But it is good for other things like disperse or size. So let's use disperse here. So let's turn up a little bit of our disperse and randomize this. Randomize the positions of our particles. And we'll control the disperse using the layer map comp 1. So this is simply a linear wipe. Let's speed this up a little bit so it goes maybe 2 seconds there. So they start displaced, and as that image wipes away, we have less disperse. And it basically goes to no disperse. We can flip it around and invert that map so it goes the other way. The same would go for particle size. So I could say map this to comp 1 over x and y and invert. So now it's going to wipe on the image. Let's turn that blur back on for our text. In fact, because it's blue, it's not pushing the particles as high. So let's change that back to its white. Whoop, wrong way. I meant black. There we go. Now we can bring the displacement strength down. Now the one I haven't covered yet is rotate. Rotate only works if we're using a custom particle. So let me just bring in a custom particle that I've made. Work with this hexagon here, and we'll make that our custom particle. So let's go to particle, particle type, textured polygon, texture, layer, particle, and we'll just sample the current time. That's just fine. Now I'm going to bring down the particles in X and Y, let's say 80 by 60, and turn up the size. Now at this point, not very impressive because it's white on white and we can't really see a whole lot of variation here. So this would be a good opportunity to turn the shading shadowlet on. This is going to add a little bit of a drop shadow behind each of these particles. In fact, I think we could still have fewer. Now, in the particle section, there's a rotation control when we're working with this textured polygon, which can, as I mentioned earlier, rotate the particles in all 3 axes. So it's the 2-dimensional image that exists in 3-dimensional space. So if I set this to 90 degrees, these should be rotated flat along the surface. So in rotation, I can set a layer to drive the rotation of the particles. So I'll use that map comp number 3. And we'll map this over X and Y. And I can control the strength. So from gray to white is going to be half a rotation, and from gray to black, it'll be a half a rotation in the other direction. So I could make this more pronounced by setting this strength to 360. That will set 1 full rotation as it goes from gray to white or gray to black. So there, we're controlling rotation and displacement using the luminance of an external map. Pretty cool. Now, you might be wondering what this time span thing is. This actually isn't going to do anything unless you're using a function down here, which is called x, y, and then time equals z plus time, which I know sounds a little bit crazy, but we'll cover that in another topic. It's a bit out there. And that's not going to do anything for you because we haven't set that. So don't worry about this time span for now. It's not going to do anything. So you might be thinking, hey, that's it. That seems pretty straightforward. Layer maps are just like quick maps, but basically have much more control because we can customize the image. Then, of course, the image itself is 2 dimensions versus the 1 dimension that our quick maps have. But there's actually one more reason, and this relates to using OBJs. Let me kind of start over here and just create a new composition. Now, you may or most likely haven't seen this little piece that I call Cosm. It was essentially an experimental piece that started with this first scene that you see right here, where these particles form this OBJ. Now you can pretty much tell that this is, this is the buckyball form, but there's some interesting things going on here. First of all, we talked about using maps to control how things form and come together. They generally go along one axis. So they go along the X or Y or Z, or maybe even like from the center out using radial. But this doesn't appear to be doing that. It seems to be almost flowing along the surface of the object in some sort of order of the surface. And that's actually exactly what's going on. When we work with 3D objects, objects have an order and a flow along the surface. We call it the UV. It's kind of like X and Y, but along the surface of an object. So instead of X, Y, and Z, we have U, V, and W. Generally, if we're working with a flat surface, we have U and V. So it's the direction of the surface and how the surface flows. There's a first point of the surface, and there's a direction that the objects kind of flow along the surface, which is the first vertex, which is the second, third, et cetera, et cetera, et cetera. Why do I bring this up? Form can read those UVs. It's actually aware of the surface of the object, as long as that information is included with it. So let me apply form here, and we'll work with our trusty old Bucky. And let's turn off that OBJ layer, go to form, base form, OBJ, OBJ settings, Bucky. There it is. Let's create our camera here and float right in close to it. Now, I bring this topic up in the layer maps tutorial because UVs are recognized by Form's layer maps, not by quick maps, but by layer maps. That goes from black to white, and apply it to the displacement in the layer maps, you'll see a completely different behavior than you would in the quick maps. So let me do that real quick here. Let me rename that layer because that's going to bug me. Now, generally when I create pre-comps to be used inside another comp, especially for form, rather than start with a comp, I usually start with a solid. So I'm going to make a solid, we'll call that map, and then hit the trusty quick key combo, Shift Command or Control C to pre-compose that. So now I have that map inside the comp and that comp inside my main comp, and all I have to do is turn that off, and I can open this up and create whatever kind of map that I want here. So generally for black to white, I just create 2 solids, 1 black and 1 white, and we'll do a linear white between the two. So go to transition, linear white, transition completion to, let's flip this direction around to -90 and feather it. This looks like it's a little bit not quite white. There we go. Map comp 4. Let's rename this. This will be our gradient map. Wipe. In fact, let's make this go fairly slow. So we'll have this go over 5 seconds. So very slow gradient wipe. So that's already in there. Let's go to Form, Layer Maps, Displacement. And actually, I can tell you I've already done this incorrectly. Maybe you've already spotted my mistake, but let's keep moving on. Functionality, individual, X, Y, Z, and then layer for X. I'll move these from one side to the other. I'll set this gradient map wipe and then turn up this displacement so that they flow from one side to the other. So this is actually good to illustrate. This is why we have to be mindful of displacement, because if we use maps that are black and white, your OBJ or whatever your base form is, it will never actually be in its original position. So this goes from white to black, we should actually have this go white to 50% gray. There we go. And if we want it to start on the other side of the screen, we can simply set the strength to a negative value. So as you can see, it's forming along the values of the surface. And actually, let's ease this in quite a bit. Actually, let's go into the map, into the graph here, and make a very gradual ease in on that. So here's the challenge with working with layer maps like this. So I've set this displacement map, and that is going to work with the black to gray. Great. Now I'm going to turn up some fractal field stuff here. So let's get the fractal displacement going. And in our layer maps, I'll go to fractal strength, layer, gradient, map, wipe. Well, it doesn't quite seem to be doing what we want. Basically, I'd like to have these affected by the fractal and then forming together and forming the object. Let's try invert. Invert doesn't seem to do a whole lot of anything. Well, this suggests to me that gray is not what we want for fractal strength. And that's exactly what's going on. We don't want gray values to control the fractal strength. Fractal strength works with black to white values, being a 0 to 100% strength. So we're actually going to need a second gradient map. Now, we can create another one from scratch, but here's what I suggest to do. Take this one, pre-comp it, we'll call this number 2. And where your areas are gray, let's reference that point in time, apply levels, and take that black point and turn this up so that gray gets crushed to black. So that's our gradient map 2. Let's go to our OBJ formation, drop gradient map 2 in here, go to form, fractal strength, map 2. There we go. So now, let's zoom back a little bit. These will be flowing through the fractal field and reacting to the fractal field as they move towards the shape. But once they land inside the shape, there is no fractal field displacement. We could do the same with disperse too, because as you remember, disperse also works with values that map black and white to 0 and 100% strength. So let's go to disperse, layer, gradient map 2. So they're both randomized as they flow in and influenced by the fractal field. That might actually be a bit much. Let's just set that to 10. Size is another one. Let's do size, map that to gradient 2. But it's actually backwards from what we want. We want them to sort of scale from a small particle to their largest size. In previous versions of Form, you'd actually have to go in and make a third map and apply an invert to that. But built right into Form is an invert map right here, per my request. And now we don't have to make a third map. There we go. Let's set a little bit of free rotation on this. So I'll go to the X base form rotation and set a free rotation of like 30 or so. Now in the example I showed you, this actually had three-dimensional particles in here, and you can also see as it played, it looked like there's this little bit of reflection map across the surface. That the particles are actually kind of 3D and they orient to the surface. That's the other cool thing about Form, is that it will read another part of the information of the OBJ, which is called the normal. There's an angle in there. And each of these vertices can look at that normal angle, and if it is included with the OBJ and you're using a three-dimensional particle, it will orient to that normal. So let's pull in our particle. Right here, that's our hexagon. Go to Form, Particle, Textured Polygon, Texture, Layer, Particle. There we go. Let's size it up a little bit. I'll set the particle size to maybe 3. And let's go to the shading section. Let's enable shading, which everything should go black because it's now going to rely on us to handle the lighting. So let's add a little bit of light. Now I'd like to get a little bit more of a solid surface look to this. So let's go to the particle and change that default transfer mode from add to normal. So they're kind of solid. Now we can turn off the visibility of the particles in the back a little bit by setting these values so that we are going to basically turn off the visibility of the particles that are a little bit further away from the camera. So let's look at this surface here. So we can go to the shading section, which we've turned on, and we can drop in a reflection map, which is often good for injecting color into particles or ambient light to match a scene, especially with particular. But in the case of form, being that we have a fairly recognizable shape here, and as this thing rotates, we can inject a reflection map that makes this surface look almost metallic, if you will. So let's go to Shading, Reflection Map. And remember, Reflection Map is only available if you're working with three-dimensional particles, the textured polygons that are available in the particle section. So let's set the particle map to this HDR image. And we can turn the strength up and down. I'm going to put a little bit of shadow lit in here as well. And I think the particle size could come down just a little bit. It looks like they're all overlapping. There we go. And that is exactly how this was put together. You can see that metallic kind of reflection on the surface there. Also, particles in the back are set to invisible because we're clipping them with the visibility section, and the particles are oriented to the surface because the OBJ contains the normal information. This is the same exact shape that I'm working with here, and this is the same exact OBJ that you should be able to use if you've downloaded the installer and looked into the form presets and extras section. So I think that's enough to cover for now for layer maps. We've gone pretty far here, but there's a lot to talk about. So I hope you are enjoying learning and working with Trapcode Form. My name's Harry Frank. Thank you so much for watching.